about data science, specifically data science in Microsoft Azure. So as Dan said, my name is Brad Llewellyn, and I am a senior data science consultant at an organization called Centelli Solutions. What we're going to talk about today is we're going to have an architectural discussion about what different types of tools we could potentially use to perform quote unquote data science using Microsoft Azure. So just as a heads up, there are absolutely no demos in this talk. It is a high level discussion of use cases. So it's driven from that perspective. Let me get my presentation going. So before we get started with that, a little bit about me. As I said, I work for an organization called Centelli Solutions. We're a data science consultancy here in Charlotte. I have a slew of certifications. Those of you who are looking to advance your careers, Microsoft certifications are a great way to do that. So I encourage you to look into those. If you want to reach out to me after this talk, you can find me at Breaking BI on Twitter. You can also find me at LinkedIn and my blog there, as well as my personal email. Also, I'm a huge advocate of community involvement. Another great thing you can do if you're looking to advance your career. In that I am an organizer of the local BI group here in Charlotte, the Charlotte BI group, as well as I'm a frequent member and speaker at different past groups as well. With that, I do want to give a thanks to the BI or to the BA group for having me. I truly believe that these chapters, both local and virtual, are really the backbone of our community, and I can't encourage everyone on this webinar enough to get out and get involved, whether by just attending, but even better, get out and speak, or even better, volunteer to help. I know that a lot of local groups and these virtual groups are looking for people to help organize speakers, help order food, help set up the rooms, all of those things. We need volunteers to do it. So I highly encourage you to get out and volunteer. Honestly, it's one of the bright parts of the week when I get to volunteer for some of these organizations. So now, on to the reason we're all here. Throughout this talk, we're going to try to answer this question, this one question. It's the one and only question that we ever need to answer when we're working with data. So for this talk, let's step into the shoes of consultants. Some of you might be consultants, some of you might be internal at organizations, but today we're all consultants. And all we're going to try to do with this talk is answer this one question. What's the best way to solve the business problem? Notice I said business problem, because at the end of the day, they're all business problems. Technology is just one of many solutions to those. So our goal here is to understand that. But before we can do that, we need to understand what best means. Best was in quotes for a reason, because best isn't always clear. So for that, let's talk for 1 minute on what a customer's primary concerns are. What does a customer really care about? Number one priority that sometimes actually gets lost. The number one thing customers care about when you propose a solution to them is, does the solution actually solve my problem? Because if it doesn't, I don't care how good it is, how fancy it is. If it doesn't solve my problem, I don't want it. Next, assuming it solves my problem, how much is it going to cost for you to build it for me? And with that, cost is not only a function of money, but also a function of time. So that's another thing to keep in mind. After we talk about implementation cost, we also get into maintenance cost, something that is often overlooked. We look at, okay, it takes me 2 months to build this. Great. Question is, after we leave, how much does it take for them to maintain it? Do they have to have a full-time employee to take care of what we built? Do they need a full-time team? 5 people, 10 people, 20 people? You never know. On top of that, we also have to think about maintenance cost of some of the Azure tools. For instance, every tool we're going to talk about today has some sort of cost tied to it directly. Meaning that we have to think about the cost of resources as well as the cost of the products themselves. And finally, this is where most tech people seem to focus, even though it's generally pretty low on business users lists. But how quickly does it adapt to changing requirements? Because throughout my career, there's been exactly one thing constant, And that is the business requirements the day we hand over a solution are not the same as the business requirements the day we start developing a solution. So whatever we develop needs to be able to change to those, needs to be able to adapt to those changing requirements. So with that, here are the 4 sets of tools we're going to talk about today. Ordinarily, at this point in a presentation, I would define what data science means. I'm specifically not doing that here because another constant throughout my career is that every customer thinks data science means something slightly different. In fact, there are some customers that think data science means wildly different things. So our goal throughout this talk is going to be able to dig past the buzzwords and really understand what a customer wants. And to do this, we're going to look at use cases focused around these 4 tools. We're going to start with a tool called Power BI. Then we're going to move on to cognitive services, Azure Machine Learning Studio, and finally, we're going to round it off with R, Python, and HDinsight. So let's get started. First, here's our business problem. I'm going to give you 45 seconds to read it. This says that the Contoso Beverage Company, we'll call it CBC, is a large beverage distribution company in the United States. So they sell drinks. Their main source of revenue is selling cases of soda, tea, and other beverages to customers all over the world. They're a retailer. And customers can place orders using CBC's intuitive website, meaning they're an online retailer. That's going to be important. CBC also sells and services fountain beverage machines. However, this is a separate branch of the business that only takes orders over the phone. So to break this down, we have a retailer that has 2 completely separate branches of their business. They have a sales branch that is technologically advanced enough to have a website, and then they have a maintenance branch, servicing branch that is not as technologically advanced. So keeping that in mind, let's look at our first tool. First tool we're going to talk about is Power BI. For those of you that don't know what Power BI is a data analytics and reporting tool available from Microsoft. The picture we see over here on the right is of the Power BI report server, and we're seeing a report, meaning these are different charts we can use to showcase our data. This is what used to be known as self-service BI. That term isn't used as much anymore as it was a few years ago, but it's still relevant. The reason it's self-service is because these reports are built via drag and drop interfaces. You don't do a lot of coding to create these visuals. There is coding you can do behind the scenes to create what are called measures and calculations and things like that. But from a purely visual experience, it's just drag and drop, meaning that somebody with very little experience can pick it up quickly. On top of that, it can also be deployed in cloud or on-premises configurations, making it flexible. So with that, let's look at our first business problem, and then we'll see why Power BI might be a good solution to it. So this says that CBC offers a lifetime warranty on all the fountain beverage machines they sell. Remember, that's the second branch of the business. The engineering team wants to perform quote-unquote data science on their data in order to find out which types of machines they should be selling and who they should be selling to in order to reduce their repair costs in the future. This data is currently stored in multiple Excel files on the manager's laptop. So with all of this, we come to the core question of this talk. Does this solve the business problem? In order to figure that out, let's take a look at the business problem again. So, business problems are always half fluff, half context, things that don't actually affect our decision. So our goal as good consultants is to be able to dig through that and get to really the key pieces that they need. So the first key piece I see here is they want to be able to identify which types of machines they should be selling. Okay, fair question. Also, who they should be selling those machines to. Finally, they tell us what their metric is, what their KPI is. So they want to figure out which types of machines and customers in order to reduce repair costs. Finally, these files are stored in multiple Excel files on the manager's laptop, meaning that one, they're not incredibly technologically advanced, and whatever solution we propose needs to be able to handle Excel files, multiple ones, in fact. So if we let everything else fade away, this is the core of our business problem. Notice the word data science is not in here because it's not important. So let's talk about why Power BI might be a good solution to this. There are no perfect solutions in our world. There are only good ones and bad ones. So our goal here is to identify why Power BI might be a good one and use that as we progress through the talk to compare and contrast against some of the other tools we'll talk about. So breaking down some of the requirements we have here, we can look at their core technical problem here, which is which types of machines they should be selling, who they should be selling to in order to reduce repair costs. Power BI has what we call self-service reporting and analytics capabilities, meaning it allows you to very easily create a KPI for repair cost and slice that by types of machines, slice that by customer type, slice that by individual customers even. Slice that by location. You can do all of that really easily in Power BI, very quickly, in fact. So that portion of Power BI really homes in on those requirements. Finally, we have that the data stored in multiple Excel files on the manager's laptop, meaning that we don't have servers or databases hosting this data. A big advantage of Power BI is that Power BI can easily ingest data from almost any source. In fact, you can look up the list of sources supported by Power BI on Microsoft's docs, and it's overwhelming the number of sources it supports. Meaning that it can get your data out of almost anywhere. It doesn't just need to be databases and whatnot. In addition, since these are multiple Excel files on the manager's laptop, you can almost be assured that they don't have database developers on this team. They don't have a database. So whatever solution we propose needs to be able to be used or even developed by these non-developers. So it needs to be accessible to what we call power users. And Power BI definitely fits that bill, given its drag and drop interface. And its language under the covers is called DAX, and it's very similar to Excel. So if they're comfortable in Excel, they will probably be relatively comfortable in Power BI as well. Some other additional pieces that aren't necessarily mapped directly to requirements is that Power BI is very quick to use. You can go from Excel files to Power BI reports in literally minutes. There are webinars that do that all the time. Depending on how much additional work you want to do, you could easily go to a full-fledged solution in days or just a couple of weeks, which really cuts down on a lot of the overhead from heavier solutions. Power BI is also extremely cost efficient. Power BI Desktop is completely free. Everybody on this webinar can go out and download it right now from Microsoft's website. And if they want to deploy it, either on premises or in the cloud, licenses for users are only $10 per person per month, which is substantially lower than most other reporting tools. So it's very, very cost efficient. Also, since it's very accessible to power users and business experts, the skill is widely available on the market. As their needs grow, as they really love these Power BI reports and want to build more and more and more, the manager might not have time to do all that himself or to delegate to one of his business experts who needs to be out interfacing with customers. Instead, he or she is going to hire, a Power BI developer, and those are very easy to find in the market. Also, as their use cases get slightly more advanced, Power BI does have the ability to utilize R in some cases, which means that as they want to go into traditional data science, in quotes, then they have that option there as well. So with that, we're going to shift this a little bit. We talked about Power BI just now. Talked about how it's a fast tool that can easily allow us to look at our data to gain quick insights. Well, that's not the sum total of all business problems. So let's talk about a completely different type of tool here called cognitive services. And then we'll take a second to kind of compare the two. So what is cognitive services? Cognitive services is a collection of 28 pre-built machine learning algorithms available in Azure. And the key here is that these are pre-built and trained using Microsoft's data from Bing and Cortana. So anytime anybody goes to Bing and types in a search, anytime anybody types in a search in Cortana on their computer or talks to their Windows phone or any of those other things, Microsoft has that data and they use it to build a whole wealth of machine learning models. So as we can see at the bottom, they have models around image recognition. They have models around knowledge capturing, models around language interpretation, not knowledge around or APIs around speech recognition, as well as the ability to programmatically use Bing search within applications. So as we said, the key is one, these are pre-built, but two, that pre-built with Microsoft's data. So Microsoft has way more data, unless you happen to work for Amazon or Google. Microsoft has more data than you do, substantially more data than you do. On top of that, they have the best data scientists in the world working for them. So it's virtually guaranteed that their machine learning algorithms are better than anything you could ever build in-house. The only question is, does your problem map to one of these algorithms? And if it does, maybe it's a good fit. So with that, let's look at our next business problem. This says that CBC's website allows customers to leave comments about their orders. The customer service team wants to perform quote unquote data science on their data to find out which types of customers and or orders tend to leave negative feedback. This data is currently stored in a SQL Server table. So with that, back to the same question again. Does this solve the business problem? Well, let's find out. So first thing we see here that's really relevant in this business problem, website. Website's hugely important here, and we'll see why in a minute. Also, they want to find out which types of customers and or orders, meaning they need to be able to identify these customers and orders, or at least their type. And they want to be able to understand negative feedback. Negative feedback is the key here. Also, this data is stored in a SQL Server table, meaning that they likely have database administrators or some sort of developers to handle that database. So everything else fades away, and this is the core of our problem. Now, with this, let's map those requirements back to why cognitive services might be a good solution here. So first, we said they have a website, and this data is in a SQL Server table. A website means they definitely have web developers, or at the very least, they have access to a team of web developers. And SQL Server table means they have someone who's capable of doing database development to some level. So these cognitive services are available as Azure APIs. And an API is a very common way for applications to talk to one another. And it's the backbone of modern application development. And it's a guarantee that any web development team will know how to thoroughly use APIs. They're also pretty common for DBAs to know as well. So organizations that have these skills can very likely use APIs easily. Now on to the business part of the problem. They want to find out which types of customers and or orders tend to leave negative feedback. So negative feedback is really key here. Power BI would be a decent solution up until now. Problem is, negative feedback isn't an attribute of data, typically. These comments come in as just free text, just got text. It's not like it's labeled negative or positive. So we need something to give us that label. Fortunately, cognitive services pre-built algorithms don't require any data or training. We can literally take one of the language algorithms. There's a language algorithm called sentiment analysis. You can literally point that right at this data and just feed it a comment, and it'll feed it back a score of how positive or negative it is. So already that algorithm out of the box just works for this business problem. On top of that, we have a few additional features. Just like with Power BI, and I promise this won't be the last time you hear this, cognitive services is very quick to implement. Since we didn't have to train these models, we didn't have to feed it training data, we didn't have to find data scientists or anything. We just point and use. It's got a very quick implementation time frame. And since they're exposed as Azure APIs, our team can get started immediately. They'll know exactly how to hit it. They can ingest it right into their application, or we can ingest it right into our ETL process if we'd like as well. The cognitive services APIs are also relatively cost efficient as well. As long as we use them intelligently, we can keep our costs down. Also, just like with Power BI, the skill set of productionalizing APIs is extremely common in the marketplace, and you can easily find more people as your needs grow. No. With that, that's the end of cognitive services. So let's do a little bit of a compare and contrast real quick. So first, we talked about Power BI. Power BI has a great ability to allow virtually anybody to slice and dice their data, to see this type of person does this, these machines sell well, whatever our question is. Very good at slicing and dicing our data, assuming we already have the data we're looking for. Cognitive services, on the other hand, is very good at giving us some data we might not already have. For instance, tying sentiment to our comments. It can also do all sorts of image recognition stuff too. It's very good for building out additional data sets or additional attributes of our data. But those aren't all the tools on the market. Let's talk about another tool that handles a slightly different situation, and then we can compare and contrast all three. So this tool is Azure Machine Learning Studio. Now, what is it? So Azure Machine Learning Studio is a personal favorite of mine, for those of you who have seen any of my other webinars. It is a drag and drop machine learning interface, effectively. So what we see on the right is we see a quote unquote pipelining interface, if you will. It looks very similar to SSIS or Alteryx if anybody's used those tools. And what it allows us to do is it allows us to have data come in the top. We perform a series of operations on that data, and then something comes out the bottom. Simple as that. It really excels at doing machine learning and data analytics. And the drag and drop interface and set of kind of pre-configured algorithms makes it really easy for data professionals or perhaps aspiring data scientists to use the tool without having to get really deep down into code and R and Python and things like that. In addition, it's what's known as a software as a service, often called SaaS. And software as a service means that we can either Google Azure Machine Learning Studio and sign up for a free workspace, completely free, no cost ever. Or we can use our Azure subscription to sign up for an enterprise workspace, and that's it. We just sign up and we go to a web link and it's there. We don't have to provision any hardware or anything. It's just there, always ready for us to use, no configuration needed ever. And that makes it very easy to just hop in and use when you need, without having to worry about all the back-end stuff. So with that, let's look at our next business problem. So this says, CBC's customer churn rate has been steady for the past 3 years. Customer churn is generally defined as when a customer stops using your product or buying from you. The account management team can see this information using their existing set of reports and dashboards in Power BI. They want to perform quote unquote data science to develop an algorithm for predicting when particular customers are likely to churn. They will use this information to reach out to these customers and attempt remediation. This data is currently stored in a SQL Server data mart. So with this, back to the same question. Does this solve the business problem? And if so, why? Let's take a look at what that business problem actually is. So first thing here, they have an existing set of reports and dashboards in Power BI. This is really key. This means that while Power BI might be good for visualizing customer churn over time, maybe even types of customers that churn more often, since they already have existing reports and dashboards in Power BI, I'm going to have a very hard time convincing them that Power BI is a solution to their problem. They already have it. They already think it isn't. So we might need something a little bit more advanced. They want to predict when particular customers are likely to churn. While a tool like Power BI might be good at telling you what groups of customers tend to churn more often, predicting when a particular customer is likely to churn is a bit more complex. That's a prediction. That's looking towards the future, not the past. Also, they need to be able to reach out to these customers and attempt remediation, meaning they need to identify this churn before it happens. Like we said, predicting the future. And finally, this data is stored in a SQL Server data mart. Now, fading everything else away, this is the core of our problem. Let's see how these business requirements might map to Azure Machine Learning Studio. So with that, first, we have some technical requirements around, they have these existing reports and dashboards in Power BI, as well as they have a SQL Server data mart. This means that a reporting solution is probably not going to fly with them. They've already got one. They know what it can do. So they need something a little bit more advanced than a reporting solution, but they have all these data professionals around that are building their Power BI reports, maintaining and developing their SQL Server data mart. So if we could give them a tool that's accessible to those data professionals, that might be very helpful. Hence Azure Machine Learning Studio. Also, Azure Machine Learning Studio supports limited use of SQL, R, and Python as well. So as our use cases get more and more advanced, Azure Machine Learning Studio can stretch a little bit to allow them to potentially use more advanced coding languages to solve their problem. Also, Azure Machine Learning Studio can be deployed using Azure APIs, which we talked about in the last case. Since they have a website and since they have this data mart, they definitely have the ability to use these APIs, which makes it very helpful. Down to the business part of the problem. They want to predict when particular customers are likely to churn, and they need to be able to reach out to these customers, meaning they need to be able to predict the future in this case. And Azure Machine Learning Studio is easily capable of creating those targeted machine learning models. Azure Machine Learning Studio can really create a model that says, I think you have a 90% likelihood of churning within the next 90 days. It can absolutely do that. And that's what they need in this case. Additionally, and probably getting tired of these exact same features, but they're important. Azure Machine Learning Studio, given its drag and drop interface and its general lack of coding, it has very quick implementation timeframes. In my experience, you can generally get from problem to solution in about half the time using Azure Machine Learning Studio as using some of the coding languages. And then that's just because of the advantages you gain of not having to write code. In addition, Azure Machine Learning Studio is extremely cost efficient as well. You can sign up for a free experiment, a free workspace, like we said earlier. And the only difference there is the free workspace doesn't scale all that well to enterprise level. But if you want to move up to enterprise level, you can pay $10 per month per user for Azure Machine Learning Studio. Same price as Power BI. Difference being that Power BI, you have to buy a license for everybody who uses the reporting service. Azure Machine Learning Studio, you only need licenses for the people who actually develop in the studio. So most organizations get away with just a handful of those versus having half your organization with licenses. The APIs also do cost money to use, but they are relatively cost efficient as well. So with that, we've talked about 3 different types of tools. Let's do a quick review. So we talked about Power BI, which is on the end of the spectrum that really lets us look at our data, visualize our data, see what's going on historically. It's very good at that, very easy for less advanced users to use. We talked about cognitive services, which really gives us that power to create new insights out of our data, create completely new fields using things like sentiment or image recognition. However, it only does some niche things. It only does certain things. Azure Machine Learning Studio opens it up a little bit. It does allow us to make predictions on all types of things, but we do have to provide our own data and our own training and our own experience to build those. So with those, let's talk about the last set of tools we'll talk about today, R, Python, and HDinsight. We'll start with what are R and Python. R and Python are the most common data science programming languages out right now, at least in my experience. The top picture up on the right you see is R. The bottom picture is Python. And they are coding languages. There is no way around it. You have to develop these. However, big advantage here is that Microsoft has put a lot of investment in integrating these 2 languages into a lot of their tools. So you can find them all over the Microsoft space. You can find them in SQL Server 2017 supports R and Python directly, so you can literally run your code in SQL Server. You can also run them using Azure Machine Learning Studio notebooks, which is not the same as the drag and drop interface we just saw. You can also use Python in the Azure Machine Learning Workbench, which is completely separate from the Studio entirely. You can also use R and Python in the Azure Data Science virtual machines, which are very interesting, as well as you can use them in Azure Data Lake Analytics and HDinsight. So you can use them all over the space. And we'll talk about that advantage here in a minute. Speaking of HDinsight, what is HDinsight? So HDinsight is Azure's implementation of Hadoop. Hadoop is the de facto big data standard right now. It really gives us that ability to extend where SQL Server might start to struggle. For instance, there's the 3 V's of big data, which are volume, velocity, and variety. So if our data gets so big that SQL Server chokes, Hadoop's a good answer. If our data comes in such various types, like pictures and videos, Hadoop might be an answer. As well as if our data starts streaming in so quickly, Hadoop might also be an answer there. However, Hadoop is not the simplest of ecosystems to use. As you see on the right, this is a language called Scala. It's pretty similar to Java, but it is a low-level programming language. And a lot of Hadoop is even programmed in Java as well. So if you think that R and Python are true programming languages, then Java and Scala are really going to give you a headache because they're even more complicated. However, Microsoft has done us a few favors here in that they've made HDinsight into what's called a big data platform as a service. That means that we don't have to worry about creating the Hadoop infrastructure, which is extremely complicated. Instead, we can go to Azure, we can click HDinsight, name your cluster, and set a few configurations, and off it goes. There are 7 flavors of HDinsight currently available in Azure, ranging from batch ETL processes like Spark, which can handle massive amounts of data, to streaming infrastructures like Storm and Kafka. There's also a separate implementation called Databricks that it is not part of HDinsight, but it's worth mentioning because it's gaining a lot of ground. So also something to look into. And also HDinsight is virtually infinitely scalable. Whereas SQL Server will eventually hit the laws of physics, HDinsight really doesn't ever. So it's a good option when you start dealing with incredible amounts of data. With that, let's look at our next business problem. So this says, CBC's online sales system contains 10,000 different products and processes over 1 million orders per day. The marketing team would like to perform quote unquote data science to recommend additional products to their customers while they use the online system. This data is stored in an Azure Data Lake store. So I'm sure you know what's coming next. Does this solve the business problem? Let's take a look. So, if we break this down, the first important piece here is they have 10,000 different products. That's a lot of products. That's a lot to maintain in an algorithm. They also have 1 million orders per day. So they have a lot of orders too. They want to be able to recommend additional products while the customers use the online system. So for every single customer that peruses their website, they need to be able to do 10,000 calculations, 10,000 predictions for every customer that roams their website, which is 1 million per day. So that's 10 billion predictions per day. But those predictions need to come back in milliseconds, quickly enough that the user doesn't notice. So we need something that's very, very scalable. And this data is stored in an Azure Data Lake store, which is Microsoft's HDFS store or big data store. And that opens up some opportunities for us, which we'll see here in a minute. So fading everything else away, this is our problem. Let's see why R, Python, and HDinsight might be a good solution here. So first, we need to be able to recommend additional products. The big advantage here is that R and Python are open source programming languages, meaning they have immense amount of libraries. Virtually any predictive or mathematical algorithm that's ever been conceived is available somewhere in R or Python. So this product recommendation problem is definitely solved in there. Now, down to the technical component of that, as we talked about before, we have a lot of predictions we need to do, and we need to be able to do them very fast against a very big data store. So HDinsight really comes into play here because HDinsight plus this Azure Data Lake store are capable of consuming these massive amounts of data. We can do these very, very fast predictions using the power of HDinsight and the breadth of R and Python. So while this problem could theoretically be solved by Azure Machine Learning Studio, which has a product recommendation algorithm, Azure Machine Learning Studio probably can't scale to the point that this needs. So this type of solution comes in really handy when we need an amazing breadth of possibilities or we need a tremendous amount of power, both of which seem to be apparent in this case. Also, something that doesn't get talked about enough is that being able to use R and Python makes for a single set of tools for data scientists. One thing that people don't often think about SQL and BI professionals is that as I've been a BI consultant for years, and I had to learn how to use Power BI, which has a language DAX. I had to learn how to use Analysis Services, which uses MDX, SQL Server, which uses T-SQL, SSIS, which has its own drag and drop interface, as well as another language. So I've had to learn 4 different tools just to do one job. That's pretty inefficient. I've had to learn a lot of things, and that's definitely slowed me down. I'm sure you have similar experiences. So there are a lot of new types of solutions that are leveraging single languages to do the entire solution. A single language across multiple products gives you an end-to-end solution that can be maintained by one set of skills instead of multiple set of skills. In fact, Python's really starting to lead the charge here. I found organizations that are using Python for their entire pipeline. Python for ETL, Python for visualizations, Python for data analysis, Python for machine learning. The whole thing, one set of skills, and it's very efficient. Also, these skills, which while they were not so common a couple of years ago, they're becoming very common. Universities and tech groups are just pumping out people with R and Python skills, as well as Hadoop skills. So we've talked about a lot. What's the takeaway here? We've talked about 4 different tools, 4 different business problems. What are we really trying to leave with? So if you're going to leave with one thing and one thing only, this is what it should be. Let's look at all of our business problems. Any business problem we could ever have could be imagined on roughly 2 scales. The vertical scale here is scope of implementation, meaning how difficult is the problem? How long does it take to solve? How much power do we need? And then the horizontal scale here is the cost of ownership. How much is it going to cost me to get this solution? So the first three tools we talked about, Power BI and Azure Machine Learning Studio and Cognitive Services, those are all toward the lower end of the scale. R, Python, and HDinsight are more towards the top of this scale, which gives us a really nice dichotomy. That means that we can use these bottom sets of technologies because they're very fast and they're very easy to use, meaning that they're generally very budget conscious. However, they have this limited scope. They don't solve every problem. Power BI is not the solution to every problem under the sun. Neither is Azure Machine Learning Studio or Cognitive Services. They have their limitations. When you can use them, you definitely should. However, there are a lot of cases where they're not the right solution. So in those cases, we have these tools like R, Python, HDinsight that, while they may be slower and more difficult to develop and maintain, they have a virtually unlimited scope, allowing us to solve virtually every problem. So it's up to us as good consultants to be able to distinguish which one of these situations we're in. Do we use the more niche tools that give us faster results, or do we invest in the more agile tools? And that's really up to us on a case-by-case basis. And that brings us right back to our original question. What's the best way to solve the business problem? With that, I'll open it to questions.
All right. Thank you, Brad. That was great. Good content. Way to cover all those different tools, and those case studies were great. Let's take a look here at our questions. We did have one question here right out of the gate that was presented. Maybe not specifically on this topic, but Bill had a question here. His question was, does linear and integer programming still play a part in BI? And does Microsoft offer a modeler and solver for setting up and solving an optimization type, least of cost or max profit type of business problem?
I might defer that to you, Danny. I don't think I'm smart enough to answer that question.
that was a multiple. I'm not specifically sure on that specific question. I would have to look into that myself. Okay. Some of the question is, so if someone's interested in going into data science and looking into whether it's R or Python, do you have any good resources as to where they might go for resources as far as getting introduced into those topics and starting to learn those type of languages?
Sure. So if anybody is looking for additional topics around how to get into data science, I have a whole other presentation called What is a Data Scientist and How Do I Become One? You can just look that up on YouTube or Google it, and you'll find YouTube videos of it. Or you could send me an email and I can send you some copies. But yeah, there's tons of resources, and I provide exact links to all of that. So.
Oh, great. Okay, another topic here. Someone was wondering also about the Machine Learning Studio. Where would they find resources on how to use that tool and leverage those components like into their applications if they wanted to?
So Azure Machine Learning Studio is less widely used than R and Python, so there are some less resources. As you can see, I have webinars on that. I know Ginger Grant has done some webinars on that as well, so you can look those up. There are some blog posts floating around from people around how to use them effectively. But I would definitely look up either webinars or blog posts depending on your style and get started with that. I will tell you it's pretty simple, so it shouldn't take much ramp up time.
Okay. Someone was wondering, could you maybe explain some of the analytic capabilities that are provided right within Power BI?
Oh, sure. There are people that devote their entire careers to just talking about Power BI and its capabilities, but at its core, Power BI is a BI in a box, if you will. It has a query engine that can allow you to query hundreds of different data sources. So virtually no matter where your data is, you can query it. You bring it into an internal engine that can do all sorts of data modeling. So it's like SQL Server inside the box. You can build different tables. You can build new columns. You can combine tables together, do any sorts of data manipulation you need. And then on the front end, you can visualize it. So it's a really good kind of prototype for the entire BI system, allowing you to query your data, transform it using a language called DAX, which is very easy to learn, and you can visualize it using a drag and drop interface. Also, like we said, it has limited R functionality too. So if you want to get a little bit deeper, you can utilize R to do things like make external API calls and build machine learning models if you want.
Okay. Someone had a question about working with like volumes of data, like which of these tools can actually scale to large volumes of data?
So their scale, Power BI doesn't scale all that well. That's one of its downsides. There is a technology known as SQL Server Analysis Services Tabular Mode, which is the same technology as Power BI, and that gives you a little bit more scale. But as your tables get billions or trillions of rows, even that falls apart. Cognitive Services doesn't really have a concept of scale because those are APIs running on Microsoft's backend, meaning that they scale larger than your system does by a long shot. Azure Machine Learning Studio scales about as well as Power BI does. It's good for 1 million rows, not great for 1 billion rows. If you need scale, if your data is getting into the terabytes or petabyte range or things like that, that's where HDinsight really starts shining. Is its ability to manipulate data of virtually any size. So I hope that helps.
Okay, yeah. Someone had a question about how deep does a data scientist have to go in order to know like statistics and programming skills? How important are those?
So that really depends how you define a data scientist. In fact, we had one. I've got a whole talk on what is a data scientist, and internally we actually have nomenclature here at Centelli, where we call all of our employees data scientists, but we have data science engineers and data science analysts. So the data science engineers generally focus on how to get data into data science solutions, and the analysts focus on using those statistical models and whatnot. So it's really a nomenclature issue. If you want to build machine learning models, you're going to need to know math at least at a basic predictive modeling level, like what is linear regression and what is logistic regression and things like that. But if you want to become, a true expert data scientist, you're going to need to go pretty deep in your math, unfortunately.
Sure, makes sense. Didn't talk about this, but someone was curious. What about Azure Data Warehouse? Could that be used instead of HDinsight, and when would you use one over the other?
Oh, that's a great question, actually. In fact, this user seems to be pretty well informed. Azure SQL Data Warehouse is not a widely used technology, but it's very interesting. So HDinsight is a very bare bones framework. It is you have to be a programming expert to use HDinsight effectively. However, there's a middle ground between SQL databases and Hadoop, and it's Azure SQL Data Warehouse. So Azure SQL Data Warehouse is basically SQL that scales really, really well. So imagine taking your on-premises SQL database and allowing it to split across multiple machines, across multiple VMs, across multiple everything. That's what Azure SQL Data Warehouse is. The big caveat there is Azure SQL Data Warehouse requires your problems to be SQL oriented, meaning you need tables with integers and strings and things like that. And it gets its power off of the SQL query engine, whereas HDinsight really allows you to expand the boundaries of that and start dealing with problems that might not be very good for SQL databases. Like recommendation algorithms aren't generally good for SQL. Graph databases are generally much better at handling SQL algorithms, and you can do graph in HDinsight.
Okay. Well, that takes care of all of our questions right now. I want to thank you again, Brad, for presenting to our community. Do you have any parting words of advice or words of wisdoms that you might like to share before we part ways?
Oh, sure. I mean, one, thanks for having me, and thanks to everyone for coming. My only parting words to everyone is that there's always more than one way to skin a cat, as they say, and there are a lot of tools that are very good at your problem, and there are some tools that are very good at all problems. So picking the right tool for the right job often gets rid of half the struggle.
All right. Good words of advice, definitely. All right. Well, thank you everyone for joining us once again. As of right now, we don't have anything lined up for July, so we might just take that off for the summer. But definitely stay posted and we'll keep you informed of any of our upcoming presentations. And once again, thanks, Brad. Appreciate your time today. And thanks for everyone for joining. Have a good day.